Yes. So, welcome to all in this course, Analog Electronic System. So, first thing, what are you standalone students? Let me.
Yes, sir.
Okay. So, I think you are aware with the what we are doing in the analog electronics system. I think you are just joined the orientation program. Okay. So, I just brief you about this one, what we are doing throughout this course. Okay. After that, so the first thing we discuss is what we are doing throughout this course. So basically, this particularly is mainly centric on the operation amplifier of PAM. Okay, so from the starting week 1 to week 7, we discuss operation amplifier. Okay, so start with the introduction of OPAM, then OPAM working as a inverting and non-inverting amplifier, then OPAM as single supply and dual supply. Can you see my screen? Wait a minute. I think I am not shared yet. Okay. So BAM, starting with the week 1 operation and week 1 to week 7 we are discussing the operation amplifier. Short form is the OPAM. Okay. Then start with the basics of the operation amplifier, then operation amplifier working. This particularly operation amplifier will be working in a two modes. One is the inverting and second is the non-inverting mode. Then operation amplifier as a single supply or dual supply. Discuss this thing. Then after that we switch on to the op-amp as integrator, op-amp for filters. Okay. So we discuss these two applications, integrator and filters. Along with that, we discuss non-ideal, non-ideal op-amp, operation amplifier. So through the week 1 to week 7, we discuss all these things. Some particularly topic will be take 1 or 2 weeks, or some particular topic will be covered in half of the weeks. So according to this one, we will cover week 1 to week 7 is these topics. Then week 8 to week 9, week 8 to week 11, we are discussing about a system development, where we start with the Bluetooth, handset, headset, or Bluetooth, earbuds. Okay, a single system. And this particularly system will be developed with the help of multiple subsystems. So week 8 to week 12, we discuss multiple subsystems. Then one is the power management subsystem, battery subsystem, sensor subsystem, okay, LED subsystem, okay, multiple more subsystem we discuss. So week 8 start with these subsystems. Okay, what is these subsystems? Now the main important subsystem is the power management unit or power management subsystem. So week 9, 10, 11 is only focus this power management subsystem. This power management subsystem is also a combination of multiple subsystems. Okay, so we go through with these particularly power management subsystem in week 9 to week 11. This is the completely course outline from week 1 to week 11. If you have any doubt, you can ask. Any doubts, you can ask me.
Sir,
Yeah.
uh, are we going to discuss the design only, or are we also going to make it physically?
Physically is not subsystem. You are asking that subsystem designing.
In the analog lab, I was asking.
Yeah, in analog, you basically design that particularly practicals are related to some operation amplifier. Okay, you go with the lab part here. In this particular lab part, you have to do two things. One is the designing on the LT spice. Second, designing on breadboard. Okay, some circuits are there, like for the triangular wave generator, filters. Okay, and multiple six experiments are total there. So you design these particularly six experiment with the help of operation amplifier, one on the LT Spice software and second on a breadboard. Okay, so that is your lab part. That will be taken separately. Any doubt? Any doubt in the lab part or any doubt in the theory part? You can ask.
No, sir.
Okay. Now, what is our teaching mechanism is that there are particularly three sessions are there, 2 hours, 1 hour, and 1 hour. Okay. So in the 2 hours, what we are doing, we just go a recap of your videos, week one, week wise videos. Okay. If you have any doubt, you can ask me in that one in a 2 hours. In a particularly 1 hour, what we do, we are discussing the practice assignment. Okay. And in 1 hour, what we do, we are discussing some questions in that one, or we can say the tutorial sheets. Okay, so this is particularly the path we follow every week. Okay, like if this is a week one, like for example, week one. So in this particular 2 hour, what I am going to do, I am just explaining what particularly professor will be explaining. If you have any doubt related to the videos, if you have any doubt related to any topic, you can ask in this 2 hour. Okay, in the 1 hour practice assignment is with you. If you are facing any issue in that particular practice assignment, we will discuss this one. Okay, if you want that I can solve this one, I can solve it, but better is that we can discuss. So this particularly 1 hour and 1 hour is the two-way communication where you are basically solving the question. I will just tell you that you are doing this mistake, you are doing this mistake. Okay, if you have any particularly question problem in the question, so I can solve it for you. Okay, if we are talking about the our quiz part, so quiz 1, quiz 2, and anthem. Till now, all three particularly are subjective. That means pen paper exam. Okay, I have already created one G space for the analog electronic system where I just add you all. If you have any doubt, you can ask the question there also. No issue in that one. Anytime if you are facing any problem, you can just drop a question here. I will tell you when I am available. I just tell you at that time. If I am available after some time, I will explain you. Tell you at that time. Okay. Any doubt till now? So just start with the operation amplifier. Yes. Okay. Student, better that you can write on a chat box. It is a better. You can speak because I have to check my screen again and again. Okay. So better thing is that you can speak. It is a two-way communication, not a single-way communication that I am speaking and you are either you are getting here that or not. You just say that okay.
Okay, sir.
Yeah. So it is a better that to you start with the two-way communication. So that op-amp is basically called the operation amplifier. Okay. If you see this is your operation amplifier circuit. Here one is the output pin, two are the input pin, One pin is the negative, one pin is the positive. Okay, and you have to apply the supply for the operational of this one. Okay, so this is a basically operation amplifier. Now this negative pin is called the inverting pin. When we go with the weak-wise content, you just I will show you that why it is called the inverting pin. The thing is that when we are providing the input at this pin, with respect to this pin, I am getting the output with a 180-degree phase shift. Okay, so that's why it is called the inverting pin. If I am connecting the input as a positive pin, it is called the non-inverting pin. Why it is called the non-inverting pin? That means when we provide the input here, we are getting the output at 0-degree phase shift. The phase shift is same. Okay, so it is called the 0-degree phase shift. Now, for the operation of this operation amplifier, we require two supplies, either the two supplies or a single supply. If I connect a plus VCC and minus VCC, that means if I apply a plus VCC to minus VCC, it is called the dual supply operation, dual supply mode. Why it is called the dual supply mode? Because we require two supply signal, one in positive VCC and one is in negative VCC. So it is called the dual supply mode. Similar, if I am giving a signal, this is my operation amplifier, negative, positive. If I am giving a VCC here and ground here, so it is called the, if I provide the VCC and ground, so it is called the single supply. Okay. Now, if we go with the internal part of this operation amplifier, so the internal part of this operation amplifier somehow like VCC minus VCC minus plus, internal there is one resistor, okay. Now if I say I apply the V1 voltage here, V2 voltage here, so what is the voltage drop across this resistor is V1 minus V2 or V2 minus V1. Any of the voltage that is greater, we can consider that V1 minus V2 or V2 minus V1. Now according to this one, this particularly will be working. So it is similarly how the voltage source. So the voltage source voltage is A time of V1 minus V2 or A time of V2 minus V1. And this particular resistance is called the R out. This is called the R in. Okay, so internally, if we are talking with the operation amplifier, so it has a three particularly component. R in, it is called the internal input resistance. Second is R out, that is called the output resistance. And third one is the voltage source A times of V1 minus V2. Okay, that is voltage dependent voltage source. I think you are familiar with the voltage dependent voltage source. Yes or no?
Yes, sir.
Okay. So basically, the circuit, the particularly source that provide you the voltage, that voltage is also dependent on some other voltage. Okay, so that's why it is called the voltage dependent voltage source. If you are in doubt, you can ask. No doubt?
Sir,
Yeah.
in one of the lectures, professor said that in ideal op-amp, the input resistance is infinity.
Yeah.
So, is it
So
the same
basically,
Rn or
yeah, what we are doing is that if I say that my input resistance is infinite, so what is the effect of this particularly thing is that if I consider that this voltage drop V2 minus V1 or V1 minus V2 should be the maximized. Why this should be maximized? Because if this one is higher, we are saying that A times of V1 minus V2 that will be maximum. And if A time V1 minus V2 is maximum, this particularly voltage source voltage is maximum, we are getting the V out is maximum. Okay. Now this voltage drop is maximum when this voltage drop will be maximum. If the current,
Zero.
or basically if the resistance value R in is high. R in is high. So that's why the input resistance should be maximum. If R in is low, so the voltage drop resistance is dropped. So that means the voltage drop across resistance is less. So that means V2 minus V1 is less. If it is less, A times of V2 minus V1. Not consider the V2 minus V1, we just say the V1 minus V2 also. Okay, so this particularly A time V1 minus V2 also. . So our output is less. Okay, so that's why the input resistance should be maximum. Now, if we are discussing about the signal system, part of the signal system, like this is my operation amplifier. We are getting a output here, V out. This one is V1. This one is V2. I am considering this one. And the input applied between these two terminal, I am just saying the V in. Okay. So if we apply the V in, our resistance is infinite, R in is infinite. So we are getting the V out maximum. Okay. And what is the value of V out? V out is nothing but, if I say this particularly operation amplifier will multiply with the gain A, because if you go into the internal part, it is a time V1 minus V2. So V1 minus V2 is V in. Okay, so if I apply the V in here, we are getting the V out here. So what is the gain? Operation amplifier A. So if V out is maximum, V in is either minimum or maximum. Other we are considering V in is minimum. So my output, what is the output? A is nothing but V out upon V in. Okay, and that value should be maximum. Like for example, I just apply V in is equal to 10 millivolt, and I am getting a V out is 100. So what is the A? 100 upon 10 millivolt. So it is a 10 into 10 is to the power 3 higher value. So ideal op amp, for the ideal op amp, we are considering the gain is maximum, or we can say it is infinite for the ideal, but practically it is not possible. But practically gain is not infinite. It is some finite value, maybe 100, maybe 1000. That is all dependent on the what operation amplifier you are using, but it may be a finite value. Yes, any doubt?
Sir, in the lectures,
Hmm.
uh, uh, professor said the ideal op-amp has infinite gain.
Yeah.
So in the ideal scenario,
Hmm.
as the gain is infinite, the voltage difference V1 minus V2 can be very small. as well
Yeah, if
as
V1
we
minus
discussed
V2
earlier.
will be small, we are getting the higher voltage, output voltage. This is the ideal case.
Okay, sir.
Okay, but practically it is not possible. Clear?
Yes, sir.
Now, I think if you are aware with the output resistance, the professor discuss about the output resistance also. We will go with the complete videos, week one videos in the next class. Okay, I just brief you about what is the operation amplifier, why we are taking this particular characteristics. Now, what is output resistance? If you go with the internal diagram, can you tell me what is the value of output resistance should be considerable? Yes. If I have a output circuit like this way, minus plus, it is a grounded, then this is the R out. So what is the output resistance? What should be the output resistance?
Very minimum, zero almost.
Minimum or zero. Okay, why? Because if R out is high, if R out is high, so this particularly A times V1 minus V2 that you are taking as a voltage, the maximum drop will be there. Okay, so if R out is high, the drop across R out is high. If the drop across R out is high, so the voltage we are getting as a output V out. So V out is less. Okay, V out is less. So what we are taking? We are taking R out should be minimum. If I am taking the ideal case, so R out value will be 0. If I am taking a ideal case, if I am taking practical case, so R out will be around in ohms, 10 to 100 ohms or 10 to 1000 ohm. This is the practical. Okay. Now again same consideration. The if I am not connecting any resistance, if I am not connecting any resistance, like this is a straight line, this is a straight line. So I just say that R out should be 0. But as you know that if I am connecting through a straight line, so this straight line will be connection through a wire, and every wire have a resistance. If you are using a conducting wire, copper, aluminium, anything, okay, so every particularly wire also has some resistance. Okay, so practically the resistance 0 is not possible. Resistance 0 is not possible. So we are taking a R out. Clear? So that's why two conditions: the input resistance should be maximum, the output resistance should be minimum. Any doubt? Yes, any doubt?
No, sir.
Okay. Now, ideally, in most of the scenarios, what we discuss, we are considering that my operation amplifier will be working with negative feedback. Okay, when you go through with the particularly weeks wise contained, week 2, week 3, week 2, you just mainly we are discussing that operation amplifier will be working in a negative feedback. Now, what is the benefit of this negative feedback is that in the case of negative feedback, we are considering the V1 is equal to V2, and that particularly is called the virtual ground concept. Virtual ground concept. That means if I am using one operation amplifier, this is my V out, V1, V2. So I just consider my V in should be 0. V in is equal to 0. So there is one feedback path is there from the negative terminal. Okay, positive and negative feedback. It is a negative terminal. So it is connected with the negative current. So all current that will be passing, because no current will be going from this side. No current will be going from this side. Why no current will be going from this side? Because V1 is equal to V2. So the voltage drop across V1 minus V2 will be 0. If this particularly V1 minus V2 will be 0, so the voltage source is again 0. This is my internal circuit. The voltage is A of V1 minus V2. Okay. So if V1 minus V2 is 0, so that means A times of V1 minus V2 is also 0. Either your gain is infinite, okay, either your gain is infinite, your V1 minus A times of V1 minus V2 becomes 0. So that means if this particularly voltage is 0, so that means you are getting output V out is 0. If V out is 0, so the current will not pass. Either you apply the V1 here, V2 here, but the current will not pass through the operation amplifier. Through the operation amplifier. Not passing. So now how the current will be passing? The current will be passing through the feedback circuit. Through the feedback circuit. Okay? Is it clear? Just wait a minute. Okay, so this particularly will not, this current will be passing from the feedback circuit. Now two types of feedback discussed in the video lectures. One is the negative feedback, second is the positive feedback. So what is the meaning of negative feedback and what is the meaning of positive feedback? So I am taking a simple circuit. Like this is my gain. or I'm taking this is operation amplifier. Now we have a feedback. Some part of that feedback I'm taking and add it into the Vin signal. It is called the error. In the feedback, if I am having some loop or feedback gain, okay, this is a type of feedback circuit. If I am taking example of this feedback circuit is that mm, I suppose I have a circuit. Mm, Suppose I am taking example like I have to maintain a room temperature. I am using a AC in my room and I have to maintain the room temperature up to the 25 degree. Okay, 25 degree. So what will be happen in this scenario? Okay, initially my temperature is 37 degree. So this is my V in the terms of temperature. This is the input signal, not a V in. I am just taking this is the input signal. That my room temperature is 37 degree. And this is the output signal. My room temperature is I maintain is 25 degree. So what I do in this case? This is the AC and this is the person. So if my temperature is 37 degrees, so I just on my AC. Okay, on my AC. So what will be happen? It will be initially start flowing. Okay. Now I compare this signal. This is a 25 degree. I require a 25 degree. Now I compare this 25 degree with the 37 degree. So I am getting a my temperature is higher. How much? 12 degree. So according to this one, this particularly signal will be going in this one. Okay. Through this one, the temperature will be start reducing. Okay. So basically 37 to 34 degree. My room temperature is now 34 degree. So my output signal is 34 degree. But what I required a 25 degree. I required a 25 degree. So again signal go back to this one. Again it will be going to this one. So now my input is 34 degree. 34 degree, 25 degree, again a 9 degree higher. Again my AC will be working. My temperature is start reducing. Now my temperature is 25 degree. So what will be happen when these two signal will be subtract or add subtract basically. So I am getting a 0 degree difference. So in this case, what will be happen? The AC will be off. AC is off. Okay. Again, after some times, my temperature will be starting raising. So when again my temperature is 27 degree, again compare 27 with the required temperature 25 degree, I am getting a 2 degree. So again my AC will be on. So basically, a feedback circuit is nothing but a control circuit. Okay, where the input as well as the output will decide that the circuit will be working or not. Okay, so this is a type of feedback circuit. Now this particularly feedback is either I am taking the feedback is a positive feedback or negative feedback. So what is the meaning of this positive feedback and negative feedback is that if I break a loop at any point, like I am breaking the loop from here, I increase the voltage. Okay, now I check through this particularly path that again I am receiving at this point is the same phase or out of phase. the signal will be in same phase or out of phase. So I just do that. One thing is that if I am taking this one is a plus, this one operation amplifier gain is plus, and this one is a plus. So what will be happen when I increase the voltage? It will be multiplied with F positive. Again, it will be added with the input signal. Again, it will be increasing in the same direction, and it is multiplied with A. A is again positive, so the same phase we are getting. So when the applied signal and received signal are in phase, we are getting that it is a positive feedback. Okay. Similarly, I am taking this is a negative. I am taking this is a negative. Okay. So if I increase a minor changes in the this particularly point, it will multiply with this one, so it will be increasing more. Okay. Now it is a minus sign, so that means it will be decreasing. If it is a multiply with A is the gain, so it will be decreasing more. It will be decreasing more. So when applied signal and received signal are in are out of phase, it is called the negative feedback. Okay, it is called the negative feedback. So for any particular circuit, if you want to check either this particularly is the positive feedback or the negative feedback, what you have to do, break a loop, change the signal. Okay, minor changes in the signal. Like similarly, this is my A, so this is a minus F, positive, positive. Okay. Now again break a loop, change a minor change in the positive direction. So when the signal is applied and go feedback, so it is a minus F. So it will be in negative direction. Again both signal will be added. So this negative signal will reduce the signal. Again this reduced signal will multiply with the gain and it will be reduced. So it is again a out of phase. So it is called a negative feedback. Okay. Or suppose if this F is positive, this is minus A. So again what will be happen? If it is increasing, it is increasing, it is increasing, but when it multiply with minus A, it will be decreasing. So again a out of phase. So it is also the negative feedback. Okay. So this is a similar, this is a concept about the positive and negative feedback. Any doubt? Any doubt about the positive and negative feedback?
No, sir.
Okay. So every particularly circuit, if I am taking anything, any control system, any particularly electronic circuit, so everywhere we require the feedback. Everywhere we require the feedback. Somehow the feedback should be a automatic feedback, or some feedback should be manual feedback. Okay, like AC. If I insert a sensor in the AC, so my feedback system is the automatic feedback. Why? Because sensor will be sense the signal, compare it with the decided value 25 degree. If I decided, so according to this one, it will be generate a signal. Manually, what will we do? We have a remote. When the temperature is less than 45, less than 25, so I just off this one, equal to or less than 25. If it is a greater than 25, I just on this one. Okay, AC will be start working. So if I control this one in a manual way, so it is a manual feedback system. If it is a control through a sensor, it is a automatic feedback system. Similarly, mobile fan. Okay, fan. We have a fan. With this we have a regulator. The regulator will be moved from 1 to 5. Now I am a person who will manage that. If fan when my fan is on and the speed is 5, so I just think that I am feeling colder. Okay, feeling cold. So according to this one, what I do, I just regulate my fan. So according to this one, I just change my fan speed is 4. Now after 4, after some time, I just feel that again it feels cool. So what I do, I just regulate my fan up to 2 or 1. After that, I was thinking, when I just move my regulator at 1, after some time I just feel that it is a little bit hot. The environment is little bit hot. So what I do, I just increase the regulator speed. So I am a controlling person. I will control that what is the speed of fan, either it is a 5, 4, 3, 2, 1. So I am a controlling person according to my what I feel exactly. So according to this one, I just regulate my regulator from 1 to 5. So I am a manual feedback system. Okay, I am a manual feedback system. So every particular system have a feedback. Without feedback, there is no particularly thing like, for example, if it is a 25 degree centigrade temperature will be maintained. So according to this one, my AC will be start working. Okay, AC will be start working. So it will be after some time it is a 22, 21, 20, 19, 18, 17. So how much minimum temperature you can uh, go with the particularly that condition. So it will be working for all the time. Okay, and like for example, you have one item or basically some particularly food item you have that is required a room temperature up to the 25 or 24 to 26. Okay, this is the range. But if my AC doesn't have a feedback system, so what I do, my AC will be start working regularly. When the temperature is 26 degree, no issue. When the temperature is 25 degree, no issue. When the temperature is 24 degree, no issue. After that, if I don't have a feedback system, so my AC will be continuously working. So the temperature will be reducing, and my item that will be suitable for 24 to 26 degree, it will be start something peeling. Okay, maybe there is some issue in the food item of that one. So for every control environment, for every control thing, we have a feedback. So two types of feedback we have, positive and negative. Is it clear? Is it clear to all?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So I think with this we just wind up. Okay. You go through with the week 1 content. In the next class, we discuss the week 1 content. Thank you all.
Thank you, sir.
Thank you, sir.